everyone. So we're starting kind of a new unit today. So your last quiz, before we got out of school, we were really close to finish factoring. So last week was a review of GCF factoring and then diamond factoring. And you guys were doing really well with the diamond puzzles, and that's awesome. So you guys took your 9B quiz last week, and so now we're going to Unit 10. Unit 10 is talking about how to graph quadratics. So last week, when we were factoring things like x squared plus 4x plus 3. So we would diamond factor, what multiplies to make 3 and adds up to 4, 3 and 1. And so x plus 3, x plus 1. And so this is called factoring. And so if you remember a degree 2 function, when we did our polynomials unit, it's been a while now, a couple months. So right before we did factoring, we did our polynomials unit. Hopefully you remember that a degree 2 is called a quadratic. So degree 1 was linear, degree 2 is quadratic, degree 3 was cubic, degree 4 was quartic. I think Jack Googled it and found degree 5 was quintic. So degree 2 is quadratic. So what we were doing last week when we were diamond factoring was specifically taking quadratics and breaking them into their two chunks to multiply together. So that was working backwards. Starting with the quadratic, and you break it into two parts that we could then box multiply together. So we called it just a factoring unit because there is GCF factoring and not just quadratics involved, but that's kind of my baby step into talking about quadratics. So we're done with factoring. This will come back. So we're going to use our factoring skills soon. But for now, I'm going to teach you guys, what is a quadratic? What do quadratics look like? We know from a polynomial standpoint that it's x squared. So a quadratic function, my printer is not working well, so I wrote this out in case you can't read it. You guys should have a nice note sheet online that hopefully you can print or write in a notebook. So a quadratic function is any function written in the form of ax squared plus bx plus c. Where A, B, and C are numbers. So A, B, and C represent any numbers that we can plug in, but this is the format of a quadratic. And if you look at this type of stuff that we were factoring, it followed that lead. Now, you can be missing one of these chunks. One of these ones can be 0, but it's a requirement that your degree is 2, so your biggest exponent value has to be 2. So these chunks can be gone. You can have one of them, or all 3 chunks. But yeah, so a quadratic has to have some form, ax squared plus bx plus c, and this term has to be there. You have to have some kind of x squared term. They actually make a pretty cool shape, and they make a shape called a parabola. And so a parabola is this bowl shape looking buddy, and it can go up or it can go down. And they can be taller, skinnier, fatter, shorter. They can be pushed and pulled and squished around, but generally it's any U shape like this, where there's one highest point or one lowest point, and everything goes in the other direction. So they can go up, they can go down, and this shape is called a parabola. So to start off with quadratics, we're gonna graph them, and through graphing them, we're gonna analyze the pieces of a quadratic. And so the first thing I want to do for graphing is just sketch a table with you guys. So I made a table over here, -2, -1, 0, 1, 2. And we're just going to practice sketching y equals x squared. And so if you notice, it doesn't really look like ax squared plus bx plus c, right? Now, technically, I just want to, it just has the x squared chunk. Well, the x squared chunk is the only part required for it to be a quadratic. Also, what's the number out front? What's the a value? Well, if there's no number out front, what's always sitting out front, even if we can't see it? A 1. So technically, this is y equals 1x squared plus 0x plus 0. Well, 0 times x is 0, 0. So we don't need to write these, and we don't usually write the 1 because it doesn't mean much. So it's really just y equals x squared. But I just want to visualize for you guys that, you can technically have these two chunks missing. They're just zeros. So technically they're there, but they're zeros. So anyways, we're going to be dealing with y equals x squared, so let's plug in -2 squared. So be careful when you plug in negatives. If you plugged in -2 squared and just wrote that in your calculator, well, let's see. I wonder if mine, I have a fancy calculator. Negative 2 squared. What do we get? Negative 4. Is that true or false? Is negative 2 times negative 2 negative 4? No. Negative times negative makes a positive. You need parentheses, right? Whenever you plug a negative in. Negative 2 squared should be 4. Because if you don't order operations, if you just type in negative 2 squared, that's the same thing as negative 1 times 2 squared. Remember order of operations. 2 squared would be 4. 4 times negative 1 is negative 4. That's how your calculator is getting negative 4. But that's not right, right? We actually mean negative 2 and 2 copies of that. Negative 2 times negative 2 should be positive 4. So don't forget to put parentheses when you plug in a negative. Always. Always, always. So negative 2 squared is 4. Next up, negative 1 squared. Don't forget parentheses is negative. Negative 1 times negative 1 makes positive 1. 0, 0 squared is 0. 1 squared is 1. 2 squared is 4. So from negative 2 to 2, these are our points. Hopefully we can see, looking at the table right now, we have some stuff come up a couple times. And hopefully we can see why that's true here once we graph it. And my graph didn't print too well. My printer at home isn't working very well, so I apologize that my notes are blue and kind of blurry and stuff. I'm doing my best. My printer's old. So negative 2, 4. Negative 2, 1, 2, 3, 4. Negative 1, 1. 0, 0. 1, 1. And 2, 4. So it makes this nice U shape, and we can keep going. If we would have plugged in 3, 3 squared is 9, so if you go over 3, up 9. And similarly, I bet you can guess that if you plugged in negative 3 times negative 3 is also 9. So at negative 3, you'd have a point at 9. So here's our nice parabola shape. So this is the graph of a quadratic. I did okay. Some notes about a quadratic. They're not V-shaped. It should not be pointy down here. It should be nice and smooth. I didn't do the best job at making it look like that. But they're not pointy. They're nice and curved. And they always have this U shape. So these ones are a little bit shorter and fatter. This one's a little bit taller and skinnier. But they always have some kind of U shape to them. And so this is the most basic that we can get, y equals x squared. There's not much else to plug in. So this is what's called the parent graph. So this is the most basic, this is the most average quadratic, nothing weird happening to it, normal quadratic. And if you notice, I usually do this in the classroom, so it's kind of hard. If you folded your paper, let's see, can I do this? Probably not. Oh, that was pretty good. If you fold your paper, the parts lay directly on top of each other. They mirror each other across this line. And so a cool thing and something that we're going to take advantage of about parabolas is because of the degree being 2, because you're squaring something each time, it makes one side of it match the other side. So when you plug in something, it's mirrored on the other side. So these points, as you go up, they're equidistant from each other. And so they're mirrored across the y-axis in this case. And that's a really useful tool about quadratic functions that we're going to use throughout this entire graphing unit. However, quadratics also can change direction. So quadratics can go up or down. And so something that tells you about the direction of the parabola is the a value. And so the a value is the number out front of the x squared term. And so you check the a value. So if your a value is positive, so it doesn't matter what number it is, but as long as it's positive, your parabola is going to be opening upward. If your a value is negative, then your parabola is going to be facing downward. Oh, my parabola got kind of messed up there. So I can show you guys up here. Let me grab a different color. Green. Sure. So we graphed 1x squared. So let's try what would negative 1x squared look like. Y equals negative 1x squared. So I'll just plug in a couple points. Make a little baby table real quick. Let's do -2, -1, 0, 1, 2. So this is where you're using a calculator. I'll show you guys. So technically what we're doing is -1 times whatever we plug in squared. So -1 times, well, our first data point is -2. And remember, when you plug in negatives, you need parentheses. -2 squared. So let's do this order of operations. -2 squared is 4. And then 4 times -1 would be -4. Ta-da! So we get -4. Let's try -1. So -1 times, we're going to plug -1 in, squared. Again, order of operations. -1 squared is 1. 1 times -1 should be -1. 0. Obviously, when you plug 0 in, 0 squared is 0. 0 times -1 is 0. 1. -1 times 1 squared. 1 squared is 1. 1 times 1 is -1. 2. -1 times 2 squared. 2 squared is 4. 4 times -1 is going to be -4. And so here's this table. Now let's try graphing this one. -2, -4. -1, -1. 0, 0. 1, -1, 2, -4. So it has very similar properties to the other one, which makes sense because we only changed one thing. All we changed was instead of a 1 being out front, we changed it to a -1. And so what that -1 did to our function is that it made it flip upside down. So when you have a negative out front, that makes it open downward. So it's opening down. So the opening part is facing down. This one, the opening part is facing up, facing down. And so depending on if you have a positive A out front or a negative A out front, that will change if your parabola is facing upward, facing downward, wherever it may live. So that's the first piece of a quadratic that I'm going to teach you guys about. And so here's just an example of a quadratic that's already been graphed. So we're just going to go through and label some key components. Currently, our arrows are pointing up, so this one's facing upward. Or actually, I should say opening upward. My bad. Opening upward. So that means if it's opening upward, that means our A value is positive. So that means positive A value. Okay. We're also going to learn about a couple other things. So as you guys saw up here, both of these, because they are very similar, they have lines of symmetry. So it's symmetric, which means they're equidistant from some line in the middle. There's some middle line that our points are equidistant from. And in these cases, it's nice and easy because it's the y-axis, because I picked, nice and easy quadratics to start with. So every quadratic has this thing called the line of symmetry. And the line of symmetry always passes through like wherever your smallest point or your biggest point is. So in this case, we have a smallest point down here. And that smallest or biggest point, this is called the vertex. And we're going to be doing a lot of stuff with the vertex. So this is your highest point, your lowest point. So that's your highest or lowest point, depending on if it's facing upward or downward. Highest or lowest point, it cuts the graph in half at that point. So that's your point that tells you a lot of information. So that's kind of like the base of your graph. Like that's like the most important point of your graph is finding where the vertex is at. That kind of anchors your graph for you. And through this point, that point is where it gets cut in half. So our axis of symmetry, and I always draw it in with a dotted line. I'm going to ask that you guys do the same. This dotted line is called the axis of symmetry. All right, so the axis of symmetry is the line which the parabola is reflected. So any point that's on this side is equidistant to this side. So there's a point right here and right here. So this one is 2 units away to the right, and this one is 2 units away to the left. So it's equidistant on each side. And as you find nice coordinate points, like here's one set, these ones are 1 step equidistant away. And so that's actually going to make it really nice to graph, because all we'll have to do is just graph one side of it and then mirror it on the other side. So we've got the vertex, the axis of symmetry. The last thing that we're going to talk about is the y-intercept. So the y-intercept is also going to help us graph. And so our y-intercept is at the point where it crosses the y-axis. And so here's our y-axis. It's labeled up here, y. And so where does the graph cross the y-axis? Well, we start here and, oh, there we go. We hit the y-axis right here. So our y-intercept, I'm going to draw one more arrow in here. So our y-intercept is at this point. So it's just like when we're graphing lines. The y-intercept is where it crosses the y-axis. It just looks, the graph just looks a little bit different than a line, right? But that term is the same. Where does it cross the y-axis? Right here at -2. So where a graph crosses y-axis. Now remember, this is supposed to be a coordinate. So for example, this is at the coordinate 0, -2. So the y value is -2, but the x value is 0. You didn't move left or right at all. This coordinate is 0, -2. All right, so these are the 3 main pieces of information that we're going to use to graph quadratics, as well as keeping in mind if it's opening upward, it's a positive a value, or if it's facing down, it's a negative a value. So these are the 4 main things about quadratics I'm going to teach you guys this week. And so I'm going to break it down into these chunks and show you guys how to find them given a quadratic equation. All right. So flipping over, I folded my paper in half. All right, so there are 3 pieces that we need to graph a quadratic. So the first thing is that axis of symmetry. That's the easiest thing to solve for first off. And so there's a formula. So axis of symmetry is equal to, so it's x equals -b over 2a. Where do these a and b values come from? Well, a quadratic is y equals ax squared plus bx plus c, right? And so we pull the a and the b values from here. And so this is the formula that we're continually going to use to find the axis of symmetry. Remember, that's just the dotted line on the graph that our parabola is going to be flipped around. All right. Also, something that's really helpful is because the vertex is the point where your graph gets cut in half, that also tells you the x-coordinate of your vertex. And that's going to be helpful in step 2 when we solve for the vertex. So just keep that in mind. So let's practice finding the axis of symmetry. So here I have a quadratic, y equals x squared minus 6x plus 1. So let's just practice labeling all 3 values. So a value, what's out front of x squared? Do you guys think it's 0? Nothing? Those are usually the 2 answers I get in common that are incorrect. If it was a 0 out front, this chunk wouldn't be here. If there's nothing out front, again, that wouldn't be here. Technically, how many copies of x squared are there? If it's not written, that means there's 1. So your a value is 1. Your b value is out front of the x term. So what number is out front of x? I'll tell you this. The correct answer is not 6. It's not 6. There's something you're missing. There's a negative out front, right? So the b value is -6. And then your c value is the chunk that doesn't have a variable. It's plus 1, so that means the c value is 1. So, however, finding the axis of symmetry, we don't need the c value, right? We just need a and b. So you don't need to label the c value for just axis of symmetry problems, but graphing, the first step I have you guys do is just label all 3 values because you'll need all 3 at some point. So axis of symmetry for this problem, x equals -b. Now, most of my students have a tendency to just write -6. This negative up here, this is part of the formula. One of the most common mistake when I'm teaching quadratics is people miss this negative. So it's not -6 up top, it's negative, and then we replace all of b. And b is negative 6. So the first thing that you should write down on your paper for these problems, no matter what, is a negative, because that's always there. And then set up some parentheses to plug in the b value. So it's negative b over 2 parentheses a value. And our a value is 1. And we go through, use order of operations, and simplify. Negative 6 makes a positive 6. 2 times 1 is 3. 6 divided by 3 is 2. So your axis of symmetry is the line x equals 2. And so I actually did a pretty nice little sketch right here already. So if this is the line x equals 2, and I usually do a dotted line because it's not actually part of the graph, right? It's an imaginary line that's helping us visualize where to flip the quadratic. All right, so that's how to find axis of symmetry. So it's just this formula. Don't forget the negatives part of it, and then you replace the b value. And the reason why it's x equals is it's because it's the line x equals. So x equals makes a vertical line through your graph. All right, so step 2, solving for a vertex. So a vertex is this point that's the base of your graph. And we're actually going to use the axis symmetry. So step 1 is find this axis symmetry value. And then plug that value back in, because we know the x value of it. The problem is we don't know the y part of the coordinate, because a vertex has some x and y value. Solving for the axis of symmetry gives us this. I'm going to call it axis symmetry. So the axis of symmetry gives you that, but how the heck do we get the y value? Well, a y value is an output. We know the function. So to find the y value, you plug that axis of symmetry value into your original quadratic and get the output. So hopefully doing an example clarifies a little bit. So step 1, we need to find the axis of symmetry. And very often I abbreviate axis of symmetry as AOS, so axis of symmetry. So the axis of symmetry is negative b over 2a. Well, let's label our a, b, and c values for this example. A is negative 3, b is negative 18, c is 1. We're not using c yet, but that's fine. Okay, so axis of symmetry is negative. Just always write down the negative, right? Just write it down every time. B value, negative 18. Over 2 parentheses a value. Well, negative 18 is 18. 2 times negative 3 is negative 6. So then 18 divided by negative 6 is negative 3. So this is step 1. So we found the x value of the vertex, so we're halfway done. So your vertex is going to be at negative 3 something. To find that something, you plug x into quadratic. So to find that something, you're going to plug your x value that you just got into your quadratic. So here's my quadratic. So I'm going to plug negative 3 in. Negative 3 times, remember all we're doing is we're replacing x with our x value. And our x value is negative 3. So we have negative 3 squared. So you're basically copying this down, but you're replacing those x spots with parentheses and plug in that number you just got. So negative 3 squared minus 18 times negative 3 plus 1. I have a feeling this is a pretty big number. I made this up this morning. If you want to use a calculator, please do so. Just make sure you're being careful. Order of operations says, what do we do first here? So most of you guys would say parentheses. Okay, the parentheses, is there anything to do inside there? Nope. Next up is exponents. Do we have an exponent? Heck yeah, we do. So the exponent only goes to the thing that's directly in front of it. So first up is negative 3 squared. Make sure you have parentheses around it, right? Otherwise it's not going to work. Negative 3 squared is 9 times negative 3. So this first chunk here is negative 27. And then we've got negative 18 times negative 3. So negative 18 times negative 3 is positive 54. So negative 27 plus 54 plus 1. So I'm just going to my calculator. Negative 27 plus 54 plus 1 is 28. So this all ended up simplifying down to 28. And so the coordinate of our vertex, it's kind of in like a random spot, right? It's at -3, 28. So it's like really high up on the coordinate. -3, 28. We're not going to be graphing this one. I just wanted us to practice these 2 steps. So step 1 is find the axis of symmetry. Step 2 is plug in. Step 1, axis of symmetry value. This gives you the x value of your vertex. X value, -3. And then step 2 is you take that -3 and you plug it in for x. Plug that value in for x. Simplify down. We got 28. -3, 28. That's where our vertex lives. All right. So we're 2 out of 3. Trust me, guys. Axis symmetry isn't too bad, finding that one x value. Vertex is the most work, right? Because you have to find the x value and then take that and plug it back in to get the y value. This is the step that's the most work by far. And it's the step that's missed the most because isn't there lots of negatives? There's lots of spots to go wrong. So make sure you're taking your time, writing down, showing your work, making sure you're getting each piece. Using your calculator properly. Remember, you can use Desmos Scientific, and Desmos Scientific, you could just type this whole thing in, right? And it'll take 2 seconds to just type this whole thing in, and it'll give you 28. The last piece that we need to graph a quadratic is the y-intercept. And luckily, the y-intercept is the easiest part. So the y-intercept is the spot where it passes through the y-axis. We talked about that from the front. So the y-intercept where it crosses the y-axis. Luckily, that's super easy when we have our quadratics like this. So the y-intercept occurs when x equals 0. So technically, we could plug 0 in. But luckily, the y-intercept is actually just a c value. And I'll show you guys why that's true. So we've got a couple examples here. So let's try actually plugging 0 in and see what happens. So the y-intercept occurs when the coordinate is 0, whatever. So if I want to know the y-intercept, all I have to do is plug in 0. So y equals 0 squared minus 6 times 0 plus 1. So I'm just going to do this first example. Well, 0 squared is 0. My equal sign's not writing because this is where I fold my paper. 0. Negative 6 times 0 is 0 plus 1. Well, 0 plus 0 plus 1 is just 1. So the y-intercept is at 0, 1. Now, hopefully we can skip this step because it's just the c value. So our a value is 1, our b value is negative 6, and our c value is 1. So if you're wondering why this whole time I've been labeling the c value, it's because it comes in handy because that's our y-intercept. So you don't need to show your work of plugging 0 in each time. I just want to show you guys that it's a coordinate. So technically what we're doing is plugging 0 in, but when you plug 0 in, any chunk with the variable is going to go away because 0 times anything is 0. So these chunks just go away and you just get 1. So for this example, if you plug 0 in, this chunk would go away, this chunk would go away, and you'd be left with negative 120. So the y-intercept is at 0, negative 120. Now it's important though that you make it a coordinate point. Don't just say that the y-intercept is negative 120. That doesn't really mean anything, right? That has nothing to do with graphing. That could be anything. So make sure you don't do that. Make sure you write it as a coordinate because technically, you're plugging 0 in. All right, so let's try graphing a couple. And then that's it for your guys' lesson this week. So for these problems, you need 3 things. You need to know the axis of symmetry, which helps you find the vertex, and the y-intercept. So the first thing I do for these problems is I label the a, b, and c values. So a is 1, b is 4, c is negative 7. And so the first thing I do is find the axis of symmetry. So remember the axis of symmetry is negative b over 2a. So for this problem, negative, always just write it down, parentheses, your b value is 4 over 2 times a. Well, you get negative 4 over 2, which is negative 2. So your axis of symmetry value is at negative 2. So we're going to go over to negative 2. Here's negative 2. We're going to draw a vertical dotted line. So this is at negative 2. So we know that our parabola is going to mirror across this. Now, let's ask ourselves, is the parabola going to go up or down? Up or down? Well, check out the a value. The a value is positive, so it's going to go up. All right, so finding the vertex. We've actually already done half the work, which is awesome. So the vertex is, the x value is what your axis symmetry value is, -2, comma something. Well, to find this part, we plug in. So here's our quadratic. Let's plug -2 in for x in every spot. So -2 squared plus 4 times -2 minus 7. -2 squared is 4. 4 times -2 is -8 minus 7. So you can go to your calculator. 4 minus 8 minus 7. Oh gosh. 4 minus 8 minus 7 is -11. Oh gosh, which barely just doesn't fit on our graph. Awesome. So 4 minus 8 minus 7 is -11. All right. So the last thing we need, so we've got axis symmetry, we've got the vertex, and the last thing we need is the y-intercept. I'm going to come over here and write it. The y-intercept. And remember, this is the easiest part, right? The y-intercept is just our c value. Well, our c value is -7. So the y-intercept is at 0, -7. So then now let's put it all together. We have these three pieces. How the heck do we make a graph? Well, my first step, I sketch in the axis symmetry, which is here at -2. So I did that. So I've taken care of the axis symmetry. So I kind of just go in order, right? I sketch in the axis symmetry. I know it's at -2, so that means it's here's -2. The x value, -2, so it's going to pass through that. Your vertex is at -2, -11, which my graph goes to -10, so my bad. So -11 would be down here. So next up is our vertex. Done. And then our last point is our y-intercept at 0, -7. 1, 2, 7. Now the problem is, we only have 2 points right now, right? So I've told you guys repeatedly that you only need 2 points to make a graph. We know what shape it makes. We know it makes a parabola. So right now, if I connected it, it would probably look something like this, right? But I only have half of it. Well, this is a line of symmetry, right? We know that if this dot is this far away on that side, it'll be equidistant on this side. So currently, from the axis symmetry, this dot is 2 boxes away. So that means we need to start here and go 2 boxes this way. Ta-da! There's our parabola. I didn't do a very good job sketching. All right. If you guys would like to, pause here so that you can try this one on your own. So pause, take a few minutes, try this one, and then start the video, and you can watch me go over it. All right, so this last one, the first thing I like to do is label your A, B, and C values. So A is -8, B is -16, and C is -2. So step 1 is axis of symmetry. So -b over 2a. So negative always. Your b value is -16 over 2, and then your a value is -8. A negative and a negative make a positive. 2 times -8 is -16. So 16 divided by -16 is -1. So your axis symmetry is at x equals -1. So I'm going to go right here to -1 and sketch in a dotted line. So this is at x equals -1. This is your axis of symmetry. All right, so axis of symmetry is done. Next up is your vertex. So I know that -1 is my x value for my axis of symmetry, but now I need to plug -1 into the quadratic. So -8 times -1 squared minus 16 times -1 minus 2. All right. So like I said, if you want, you could just type this whole thing into Desmos, like with the parentheses and stuff, and you could just be done. But we can do order of operations. -1 squared. -1 squared is 1. 1 times -8 is -8. Negative 16 times negative 1 is positive 16 minus 2. So negative 8 plus 16 minus 2 is 6. So your vertex is at negative 1, 6. Negative 1, 6. 1, 2, 3, 4, 5, 6. All right, so we've got our vertex done. And then last up is y-intercept. And it's 0, comma, your c value, which is negative 2. 0, negative 2. All right, and then if it helps, ask yourself, should it go up or down? Well, check out that a value. Oh, the a value is negative. So should it go up or down? Down. Well, let's check. I have my vertex up here. Your vertex is either your highest or lowest point, and then my other point's down here. So it's going to look like, it's going to be really skinny. And then remember, I only have half of it right now. To get the other half, I sketch it on the other half. So right now it's one direction that way. So I'm going to go one direction that way. This is a really skinny buddy. I did not do a very good job making it look symmetric. All right, so this is a really skinny parabola friend. We've graphed the y-intercept. It's going down. All right, so here's some examples of graphing quadratics. Your guys' homework this week is going to be graphing quadratics on the online format. What that has you do is just plot the vertex and the y-intercept, and then that takes care of the graph. So, unfortunately, I don't have a way for you guys to be able to sketch in the axis of symmetry. If we were in class doing it on paper, the first thing I'd have you do would be to sketch in that axis of symmetry. But the online, there's no questions like that, or there's no way, it's like not open-ended enough for me to be able to do that. But just keep in mind that the axis of symmetry is there. Your parabola is symmetric around that line. But yeah, the y-map is going to have you click on the vertex spot first. So negative 2, negative 11, or negative 1, 6. Click there first, and then it'll have you plot a point on the y-intercept, and then it'll be done. All right. So I'm going to post an answer key to the y-map questions tomorrow on Monday. Please let me know if you have any questions. I know this is kind of a lot, but just to recap, there's 3 major things. Finding the axis of symmetry, finding the vertex, and the y-intercept. And also asking yourself, is it opening up or down? That can help you sketch. Having your notes out's helpful because there's a formula you need for axis symmetry, negative b over 2a. Make sure you're labeling a, b, and c values. Be careful when plugging back in because of all the negatives. It gets messy, the squared, the negatives, all that good stuff. I would suggest using Desmos Scientific and just typing this thing in and getting the answer out instead of doing it by hand. Or if you have a fancy calculator like mine, you can also just type everything in. But yeah, Desmos, you guys can just Google it, Desmos Scientific. Y-intercept is just a C value. It's a nice hack. And then bring it all together. Graphing it. Your 3 pieces, plotting the points, calling it a day. All right, guys, hopefully this video is helpful. Hopefully this stuff can make sense to you guys. If you need, please ask me questions. Please email me. We can email, set up Zoom meetings, whatever you guys need. Please also make sure you get started on the homework, and then that way you guys can bring your homework questions to our Zoom class meeting on Tuesday, where I'll be going over this stuff. All right, guys, thanks.